We are trying at FinalSpark to build computers from living neurons because they are 1 million times more energy efficient than digital processors, and we believe that's the future. To build a better model, you just need to spend more money on energy. We propose to use living neurons as alternative because they require much less energy for processing information. So we get neurons, human neurons from human skin. Today it's possible to reprogram skin cells in order to get stem cells. And from these stem cells, we can get any type of cells we want, including neurons.
It's a digital butterfly, right? And so the neurons are controlling, doing the processing. People believe that AI could be an existential threat to humanity.
Because the engineers and scientists have to think about these consequences.
How do we address the concerns that are we creating like a matrix scenario or, like an Atlas cloud that humans will be harvested as biomatter and fuel, whether it's investors or, anybody that have these kind of concerns? How do you address those concerns?
So we try to combine these two things, AI and engineering and biology, to try to build new types of computers. But I think that using living neurons will be totally revolution. So you will just have totally different hardware. And today we have some incremental changes in digital AI. But using living neurons will be...
All right, everybody, welcome to the AI Space Podcast. I have Dr. Ewelina Kurtys from FinalSpark. Dr. Ewelina, tell us what we're going to cover on this episode.
So hello, everyone. I am Ewelina Kurtys. I'm strategic advisor at FinalSpark, which is a startup which try to build computers from living neurons. So in this episode, I will tell you what is this, how it works, and why we want to do this, why we believe that this is the future of AI.
Awesome. AI isn't just the future. It's a force rewriting the rules of business, wealth creation, and society. If you're a founder, innovator, or technologist, this is the AI show for you. The question you have to ask yourself, will I blaze a path, follow the crowd, or be left in the dust? This is a 20-second episode, and we're thrilled to have Dr. Ewelina Kurtys, strategic advisor at FinalSpark. FinalSpark is a company pioneering the development of biocomputers made from living human neurons. This technology aims to create computing processors based on biological neurons as an energy-efficient alternative to silicon chips, representing a new frontier in AI and computing innovation. Dr. Ewelina is a scientist turned entrepreneur with a PhD in neuroscience with over 20-plus peer-reviewed papers. After academia, she transitioned into business development and technology commercialization, advising tech companies on sales, partnerships, and market strategy. She's a strategic advisor at FinalSpark, where she applies her expertise in neuroscience in a deep tech project on building next-generation biocomputers from living neurons. Hi, I'm Sanjay Kalluvilayil, founder and CEO of Stonehaas Advisors, your trusted advisor for AI founders and businesses focused on GTM strategy and execution. Dr. Ewelina Kurtys, first of all, welcome. Here on the AI Space Podcast, we just dive into the insights that help founders to grow and scale. What do you see as the hottest trends in AI for 2025?
I think definitely it's generative AI. It's something what we are learning how to use in our work more and more. So I think this is the biggest trend currently.
Generative AI. Okay, great. And then also you're going to be talking about some of the things that you're working on. What do you see as that? What would you identify that category, the things that you're working on?
No, I think this is future of AI. That's totally different thing. And I think the future of AI has to be more energy efficient for sure, because we can see that AI today is using exponentially increasing amount of energy. So it's very important to optimize this to make it more energy efficient. And what we see as the future of AI is biocomputing. We are trying at FinalSpark to build computers from living neurons because they are 1 million times more energy efficient than digital processors, and we believe that's the future. But that is something what will be ready tomorrow. So we expect to have our computers ready in around 10 years. This, of course, also depends on our discussions with investors. Once we accept an investor, we can rely on 10 years timeline. So far, we are self-funded, so this might take a bit longer for us to do our research.
Yeah, we definitely want to get into this whole concept of biocomputing and being more energy efficient, and that's definitely the long-term vision. So what do you see as the top AI strategies to grow and scale a business?
Well, I think today, definitely automation and using generative AI to automate actually the tasks which are repetitive. That's actually nothing new, because that was always the purpose of AI, to automate the repetitive tasks, to try to make our work more efficient. And I think that especially today with the recent advancement of LLMs, it's more and more possible. So definitely. And I think that when we come to biocomputers, which is the future, I think that's the same actually, that it's all in the direction to make AI more accessible and more widely used.
Yeah, no, and a lot of people think about AI automation. They say, why do people are doing these types of things? But when you're a business owner, you're allocated scarce resources, and we have the responsibility as business owners to use those resources wisely, right? Whether it's energy, whether it's capital, whether it's people, whether it's time, talent, etc. Right? We have to find the most efficient ways of doing those things in a responsible way, right? So I think those are just some good insights. So let's take a step back. Welcome to the show. I'm excited to talk about the future of AI and where it's headed. Could you tell us a little bit more about your background, what led you on this foray into AI, and your path to FinalSpark?
So I have PhD in neuroscience. I did my research in this field, and after I left academia, I started to work with startups, and I learned about artificial intelligence. I realized how much possibilities it can bring, and I became fascinated by that. I started to work on commercial applications of artificial intelligence, and later I started to work on the future of AI, which we believe is biocomputing. And biocomputing is a great field for me because it's connecting my academic experience in neuroscience and also commercial experience with AI. So we try to combine these two things, AI and engineering and biology, to try to build new types of computers, which will be computers with processors built from living neurons.
Great. So, what was your interest in neuroscience? How'd you get involved in neuroscience? And what exactly did you do in that space?
Well, I always wanted to be a scientist. I don't know why. It's just the first time I've heard about this. I knew that this is something for me. So this is hard to say why we like this or other things. And then I realized at some point I was doing different projects in different fields of biomedical in my as a master student, and then I realized that the most interesting topic is human brain. So I decided to go in that direction. And I did PhD in brain imaging. So this was very cool. I really like it because there are many non-invasive methods where you can look inside brain without opening it. So I was doing this kind of research. And that was actually also gave me transition to industry because my first job in industry was also an imaging service. So on the company which was doing services on medical imaging. And this is also how I learned about AI because AI is very widely used in medical imaging. So after I realized that you can use AI for many other things, not only medical images. And that was really great discovery for me.
Yeah, before I did my master's and my MBA, right? Actually, my undergraduate was in psychology. Long story how that happened, but I was definitely fascinated by the human mind and the human brain, how it works. All from, more also from an internal perspective in terms of how do I manage myself, but also understanding others in society. The interesting part is like I actually started off in management consulting. Half of the job in consulting a business is a lot of psychology, right? It's really asking the right questions, using very logical thinking in terms of statistical models, challenging concepts, right? Talking to other people, engaging. So there's a lot of psychology to it. And then especially when you become a leader or a manager in a business too, you have to manage other people. And there's a lot of psychology to that in terms of organizational psychology and, performance, et cetera. Right. So, and now that we're getting to AI, like the whole concept of AI was how do we replicate the human brain in a sense, right, through machines and compute, right?
Mhm. Well, maybe not replicate, but definitely we inspire how to build AI based on how human brain is
Yeah, yeah.
working.
Well, in the beginning, they were trying to model it on, model on the human brain in terms of the neural networks, etc. So, how did you get into your transition into entrepreneurship?
Well, I was always curious. I was exploring a lot, and I was, of course, not sure what to do with myself. But it's more a little bit of coincidence, a little bit of networking and exploration. And I realized that the place for me are small companies. And then also because I'm living in the UK, that's also very a good environment, I think, for entrepreneurship, because it's very minimal bureaucracy, and I think it gives a lot of opportunities to set yourself free. So I think it was just a good time, good place for me, at least. And that was my transition. And I was in London at the time, so that was also good, because I think London brings everything what you want. If you want to do research or work in industry, you have a wide variety of choices.
Okay, very good. So tell me a little bit more about your role at FinalSpark.
So I'm a strategic advisor at FinalSpark, and I work on the commercial side. So anything what is related to our scientific collaborations or investment. We also have first clients, because our lab is available remotely to the scientists and clients all over the world. So we have collaborators globally. We also have first clients who pay subscription to get access to our laboratory, just to do some fundamental research in signal processing by neurons, because that doesn't work yet. We cannot yet offer computational power, but we can offer a tool for people to get familiar with how the future might look like. And we are doing a lot of our internal R&D, of course. We are submitting a lot of patents and developing our technology. And we also try to communicate this. So we also talk with press, with journalists, because we would like that more people know about this field, about biocomputing. And actually, our main motivation is because we would like that investors are not surprised when they hear about biocomputing, that they maybe heard about this before.
Yeah, I think we're going to definitely dive into the biocomputing today and talk about, some of the, a lot of the advancements and the positive things. And I'm sure there's some concerns around that, and we'll make sure to address that. So tell me a little bit more about FinalSpark. What's its mandate, its target segments, its use cases. So for those who don't understand, let's get into a little bit of detail. So what exactly are y'all doing and trying to achieve?
So FinalSpark was founded in 2014 with the objective to build thinking machine. The founders, Freddie Jordan and Martin Kutter, they're Swiss entrepreneurs. They have PhD in signal processing, so they're more on the mathematics side. And they did for a few years fundamental research in artificial intelligence in digital. And they realized that it costs too much energy. To build a better model, you just need to spend more money on energy. And indeed, we can see this today, the great success of ChatGPT and other models, very intelligent AI models, is in big part due to the huge cost of energy. So they realized, the founders of FinalSpark, that if you want to make a difference in AI, as a small startup with limited resources, you have to figure out something more innovative, not try to repeat what big companies are doing with a big budget. So they decided to try with some different substrate. And because our first employee, Jean-Marc, he had already some experience with working with living neurons, because he had a chance to do a project with Professor Markram, who is very famous neuroscientist in Switzerland. He had already some experience, so they thought it's good starting point. Maybe let's try to work with neurons. And they set up a lab. They learned biology from the scratch, and they set up laboratory in which we are doing fundamental research on how neurons are processing information. And the main objective is to build a processor, a computer, which will process information using living neurons.
Right. And so actually on the previous episode before this, we had Atlas Cloud on and saying that actually infrastructure and compute cost is a silent killer of AI startups, right? And if you can't manage the compute side, right, it's very difficult to be profitable and to grow, right? So what you're trying to do is find an alternative, because these AI, especially OpenAI and others, are spending millions, probably monthly, on compute costs, right? And it's consuming, right? And is there an alternative to do this to grow more in a different way, right? So you're using human neurons. So are you extracting neurons from a human, and what's that process?
So we get neurons, human neurons from human skin. Today, it's possible to reprogram skin cells in order to get stem cells. And from these stem cells, we can get any type of cells we want, including neurons. So that's a very efficient method. You can get huge amount of neurons in a very easy way.
Right, and then do you have to? I will get this more at the end when we talk about ethical and responsible AI, because I want to learn more and listen more before I ask any questions or challenge any questions. But so, do you have to continually get new neurons, or can you replicate the neurons or clone them, or what's the process?
No, you proliferate, you can get a lot of stem cells, and these stem cells, you can reprogram them in order to get neurons.
Okay. So, and then, so you're using the neurons to kind of as an energy source, I guess, to to grow to develop the AI. Are there any specific use cases or verticals you're addressing with? So, what is the actual solution you're providing to the marketplace?
So we don't use neurons as energy source. It's rather that neurons are alternative processors. So like today you have CPUs or GPUs, which you use to process information in the computer. We propose to use living neurons as alternative because they require much less energy for processing information. And we believe that everything what is today run on artificial neural networks would be much more efficient to run on living neurons. And especially the tasks where the speed is not important. So, for example, generative AI. We believe that would be a good case for living neurons. Although this is very early stage, because at this stage we were able to store 1 bit of information in living neurons. So this is very early, and all the possible application is still a speculation. So it's still a long way to go.
Thanks for that clarification. I misspoke earlier. What I should have said was, I guess, as an alternative to the chips that are produced by NVIDIA and AMD, and now
Yes.
there's a big announcement that NVIDIA is investing in Intel, who's been struggling. I don't know, maybe it's 5 billion. I just saw something this morning to get.
Mhm.
So instead of using semiconductors and silicon, right now we're using biomatter in a sense, or neurons to be the chips and to be the processing power correctly. And then through that, we're going to save energy and be more efficient in the long run.
Yes.
Okay, very good. So, what about the AI Space podcast resonated with you? And maybe, hey, I want to be a guest on this show. We're still fairly new. So, what resonated with you?
Well, we are trying to reach out to podcasters, to anyone who wants to talk with us, because we want to promote this topic. This is quite new direction in artificial intelligence. So still many people are not aware of this. And actually, we believe anyone who is interested in AI can also get interested in biocomputing.
Yeah, one of the reasons when I started this show was, someone had reached out to me about a podcast and said, "Hey, you want to do a podcast?" I said, "What can I do?" And I said, I'm trying to build out in the AI space, right?" And I said, "Why don't I give back and invite other people that are building out in the AI space with, bootstrappers, innovators, executives from different companies that are actually doing real things in the AI space to give others insights on how to grow and scale their business." So that's why I think, especially, we've had founders and executives, and now we have someone with a scientific background and a strategic advisor on the commercial side to kind of grow this. So, appreciate you coming on. So, before we continue, I want everyone to follow Ewelina Kurtys and FinalSpark. Definitely like, comment, subscribe to the AI Space podcast, because that helps us grow the show and get more impressive guests like Ewelina. And then, if you're also struggling in this space and need someone to talk to in terms of growing and scaling your business, schedule a meeting with me, a 15-minute meeting, and we can talk about how we can help you out. So, a lot of times people focus on technology, right? But I like to start off around vision, mindset, and strategy. So, what do you see as this critical insights, whether you're a scientist, entrepreneur, or long-term success around vision, mindset, strategy, right?
I think you need to enjoy what you are doing, and it's better to do this just for pleasure of doing this, not for the results, because especially in long-term projects, the results are never sure. So actually, it's both on in science and in entrepreneurship. I think you do a lot of things which also might not work. So it's very important to enjoy, and also to surround yourself with people who make it easier for you. So you should like people with who you work. And I think actually entrepreneurship give you these great opportunities that you can choose what you do, with who you work. You have more freedom. It also sometimes more risky, of course, but you get also freedom, and you can choose to do things with people which you like. And I think that's very important, because very challenging projects might not work. So it's always a risk. So you don't do this for results. You rather do this for a pleasure of doing this. That's at least my personal perspective.
No, I found out if you're passionate about something and you're doing the right actions and other things, the results are an outcome, right? And sometimes when you
Mhm.
focus on the results, you can be miserable. And we've talked about different episodes too. You can get under a lot of stress and health issues and other things. And the best thing to do is take a step back, and why you're doing something right, and there's the road, and adapt to get the results right. So in terms of growing and scaling a business, right? I mean, that's where you're kind of trying to do, is grow and scale, especially from a commercial perspective. What insights do you have on how to grow and scale, especially at this early stage?
Well, I think at the early stage, you don't really scale so much, because early stage is usually with very small number of people. And this is good because you have a lot of flexibility. So this is actually great. But once the project become bigger, I think it's much more challenging. So we are currently talking to investors at FinalSpark. We are seeking 50 million Swiss francs, which is around $50 million. And this is actually for scaling our research, because it's very difficult problem. So it cannot be solved with too few people. And actually, the more people work on the problem, the biggest chance it will be solved. So we actually plan to scale our R&D team. That's the most important, actually, to put a lot of effort in doing this research, so that we can get results faster. So I think it's maybe slightly different company. Like you have sometimes a lot of, I don't know, SaaS companies. Then you much more focus on marketing, on promoting your product, or trying to convince people to use the demo. But I think in the deep tech is a little bit different problem. You just have to have a maximum good team and excellent people who can solve these difficult technical problems. And once it works, it doesn't actually need so much marketing, because if you have computation power which will be 10 times or 100 times cheaper, then it brings such a great value that we believe it doesn't need so much marketing later. So actually in the deep tech, it's more scaling the research so that we can get the product as fast as we can. And in this case, it's still 10 years, so it's very long timeline, but the problem on which we're working is very difficult.
I can also give a perspective too, because my primary business is on the consulting side, and I launched this podcast, right? And it was supposed to be a
Mhm.
turnkey service, but I found out this was turning into a full-time job, because I was spending a lot of time on the QA, on the titles and the descriptions and the thumbnails and other types of things. And I said, in terms of, I've been
Mhm.
upskilling in AI. I'm an AI generalist now, in the sense of taking
Mhm.
have different skills. And so actually what I did was I actually pulled a lot of stuff in house, and brought in a new team. I actually cut about, what was it, 60% of cost
Mhm.
by doing that. And then
Mhm.
I'm improving the quality. I'm using some automation and AI tools to streamline some of my processes and be more efficient in doing things too. So especially, I think what you said earlier about, first of all, I think it was on the Joe Apfelbaum episode from Eddie AI, where he talked about, we talked about your network and your community and how that's going to help you grow. And you, like you said, working around great people. But when you are cash strapped and bootstrapping, et cetera, on certain things too, right? I think AI is an opportunity, especially a lot of these tools, to be able to be more efficient in your business, improve the quality, and actually generate an ROI. And so those are critical things, whether at different stages, right? Any thoughts on that?
Yes, I think I agree with you.
Okay, very good. So let's get a little bit. I'm sure everyone wants to know about the technology. So tell us a little bit more about the technology approach, maybe the architecture and stack at FinalSpark, in terms of how you're approaching this.
So the architecture is different, because we try to use living neurons. So how we do this, we try to use neurons. We make such round structures of neurons in 3D. and they consist of around 10,000 neurons each, and they have around 0.5 millimeter diameter. We place them on electrodes, and in this way we can send electrical signals to neurons and we can receive the response, because neurons naturally they have electrical activity. And the whole idea is to make sense between this input, which we send to neurons, and what we measure outside, which is output. And this is how we try to program neurons. And everything is, of course, connected to the digital hardware. So at the end, doing experiments in our lab means that you write a script in Python programming language, and then everything is controlled automatically. So that's why it doesn't matter if you sit in our lab in Vevey in Switzerland, or if you are anywhere in the world and access the lab through the internet browser. The effect is the same, that you can run experiments and collect the data. So that's something nice, and it shows the future of also science, because I think there is more and more automation for many reasons in the labs, and that's is interesting example of this future of how we will do research, that you will not have to go to the lab anymore. In many cases, of course, not always. So yeah, so that's our approach. So we try also to trigger neurons with some chemical signals, because in your brain, when you learn, your neurons are processing electrical signals and also different chemicals, for example, neurotransmitters. So we have also such trials that we try to release to the medium dopamine, which is a neurotransmitter. So it will hopefully affect the behavior of the neurons. And all these things, all these experiments are aimed to learn how to process information with neurons. So that's our approach.
Well, that's interesting because I think Jeffrey Hinton, considered the godfather of AI, and a lot of the other folks that were starting off in AI, right? As what we see as AI today is right. The evolution of neural networks, etc., mimicking neurons. With or at least the processes using technology and compute, right? And you're actually kind of going back to the source and saying, hey, instead of using silicon and machines in a sense, right? We're actually using neurons to, I guess, evolve AI in a sense, right?
Yes, absolutely, that's true.
So I guess that takes a lot of human brain power, intellect, and capital to be able to do some of this, right? I know it's not an easy process. So going from I guess, developing this technology, do you have any insights on that you can share? Obviously, no secret sauce or anything like that, but in terms of how you approach this in building this out, right?
So currently the project is self-funded by the founders, Fred and Martin. They have another company, AlpVision, which is very successful commercially. So this is why they can fund this new project. But as I mentioned before, we also talk to investors. We seek 50 million Swiss francs, which we believe will accelerate our research, our product development. But we also think that the technology, once it's work, it will be very profitable. We project billions of profit, actually, because it will be such a huge competition and much cheaper as compared to the digital software.
Yeah. So
And
this
hardware, digital hardware.
right. So at some point, this could potentially displace Nvidias and the AMDs of the world in a sense, right? Too, right? Unless they.
Yes, that's objective. Also, although it's still a long way. Yes,
Yeah,
but
yeah.
maybe not replace, but
Or well, they could evolve into
actually,
this space too.
no, actually, I think the market of AI will be increasing anyway. So there will be new chips, new technologies, but that doesn't mean that digital will disappear. I personally believe it will not. I think we will have in the future bigger variety of chips, variety of technologies. Um, so I don't think digital will disappear.
Yeah, right. That's a good point. It depends on the use case and also the business case around it, right? Which one makes more sense from a cost and a profit perspective to generate the appropriate ROI. So on a previous episode with Babak Hojat, the CTO of AI of Cognizant, we talked about in the general space, like with Meta and all these things, these multi-million-dollar bounties for AI researchers and scientists, etc. In terms of how are obviously you have something that's very interesting. How are you able to attract talent and do you have to put any big bounties on these folks, or just because of the nature of the work that people are willing to come join your initiative, right? Your venture.
I think when you work on such an innovative project, it's actually not difficult to attract talent because we get constantly requests from people who would like to work with us. So I think it's not such a challenge. It's more important actually for us currently to accept some investors, and in this case, we can increase our team. Of course, we are demanding because this is a project for people who can combine understanding of biology and engineering. This is something new, but there are many young people who are already into this because there are new masters mm, studies now available, so that students are learning both biology and engineering. So this is very cool. So yes, but I think that a lot of talented people are interested in that, and people are coming to us, and they are willing even to work with for free with us because they want to take part in something nice.
Well, even if by taking part for something free, right? Within a year or two, they're going to be so much more valuable, you know, as an
Mhm.
individual, but also in the marketplace too, right? Getting that experience, that insight, which is amazing. Yeah, so I'm hoping that in my audience, if you know people in the neuroscience space, medical space, and haven't even thought about you know where AI is headed in this space and leveraging your talents. Obviously, go become doctors if you want to be doctors, etc. Right? Or but this is another opportunity for people that have studied in this space that a growth area, right? So one of the other things that you had sent a link to a video, a demo on a butterfly. So maybe describe that for folks. I'll show up on the screen when the podcast comes, but describe the butterfly demo.
So this is kind of a demonstration on what you can do today with living neurons. You can play with the butterfly, and this is a web application which is connected to our living neurons. So that's why it's not always active actually, because it has to be connected to real neurons. We don't do any simulations there, so sometimes they are down. And you can manipulate the movement of butterfly, and it when you manipulate the butterfly, it will also send a signal to the neurons in our lab. And if activity of neurons will pass some threshold, the butterfly will fly where you want it, and if don't, then it will stay in the place. So that's the whole idea on how, in this case, neurons are controlling the movement of butterfly.
So it's a digital butterfly, right? And so the neurons are controlling? They're kind of like the doing the processing. Is a human there like using a mouse or some sort of device to try to control it and to send some electrical impulses that pass a threshold? So it would tell me about that process.
Yes, you use the mouse to control, but to point the direction for the butterfly, and the system is connected to neurons, and the neurons will decide whether the butterfly can move or not.
So let's be a little bit more precise. So do they decide, or is it based on? I guess there's a threshold in terms of an electrical impulse where. So
Yes,
you're more
and this
scientific than
threshold,
my. So just for those that are in the scientific audience, how
Mhm.
does that? What is that process?
So the threshold kind of decides. So it's
It's like
just
it's a
the
wire
process.
that's tripped, basically, right? If it hits a certain threshold, if it passes that point,
Yes,
then it goes. It's a trigger.
yes.
Okay,
Mhm.
very good. And so what beyond the butterfly, right? What is the future? How this technology can be used?
So as I mentioned, we believe in generative AI. That's one of the tasks we discussed a few minutes ago already. So, of course, that's all still speculation because it's a long way, but that's what we think today. That generative AI will be good case for living neurons.
Okay, and then what we know is generative AI today, right? As I'm reading some more things, and there's a was it the there's a paper we talked about earlier where once you get to more than 1,000, I think it was 1,000 iterations, kind of like these LLM models, these generative AI models kind of break down in
Mhm.
terms of their reasoning. I have a question right now, thinking about these models, right? Right now, mostly they're predicting the next word in a sequence. I think in the next few years, I don't think this is going to be sufficient for AI, the current foundational models. I think something else will have to come along that's more in terms of actual reasoning, in a sense, right? And maybe through the neurons, what you're doing that can impact that in the next evolution of AI. What are your thoughts based on what you know about, you know, reasoning and processing, and then the current state of these foundational models? What are your thoughts on where it needs to go?
Well, about digital AI, I cannot tell you because I'm not really an expert. I think it cannot fundamentally change, although maybe people have some ideas how to improve uh, digital AI. I know that there are some attempts also to get some digital AI which is also inspired by human brain even more. But I think that using living neurons will be totally revolution. So you will just have totally different hardware, and it will be just completely different. So I think it will be revolution. And today we can have some incremental changes. People are working on some small changes in digital AI, but using living neurons will be a huge revolution.
Yeah, so I use a lot of these tools in terms of ChatGPT, Perplexity, some of the creative models out there to create art, and a lot of times it seems like it's reasoning or thinking, but sometimes I'm thinking it's just like like a lottery sometimes in terms of, is it just really trying to guess? It's like really trying to be like a pretty clever student, like on a test trying to guess the answer sometimes, because there's times where it seems like really smart, but there's times where I go, it makes the same two or three. Sometimes they hallucinate, sometimes they make up stuff, sometimes they're inconsistent, and I have to say, pay attention, act as an expert. And so I still think there's a long, or at least from my perspective, I think there's still a long way these models have to go and evolve, as a user. So that's just my thoughts. What else from a commercialization perspective? Obviously, you're trying to get investors and other folks to invest in the business, right? What else from a commercial perspective do you see in the next 3 years that needs to be focused? Once you get the money, right? Then what happens after that?
So the next milestone is learning in vitro. It's for 2 3 years once we get investment. And learning in vitro means that we want to be able to teach neurons something. We can change connections between neurons in vitro, and it's the same process as you learn in your brain. We all learn in our brains that when we learn new stuff, the connections between our neurons are rewiring. So some of the connections disappear, other connections are formed or maybe strengthened. So that's the objective. So we want to be able to perform some simple algorithm for learning, maybe some image recognition, some simple classification. That's the objective for 2 3 years after the investment.
So, are you training or teaching these neurons in the sense of conditioning, reinforcement, like traditional psychological methods that are used on humans? Are you applying that to neurons too?
Yes, definitely. There are some frameworks. There are some, let's say, algorithms which are existing in nature, like you try to learn through feedback loop or associative learning. So yes, definitely we use because it all works also on the fundamental level, on the level of neurons.
Yeah, I've been reading some books on how you learn, and when someone learns a piano, right? If they stop when they make a mistake and start all over, they actually b- can get to mastery sooner, because what I guess in the human brain, the human neurons the synapses, there's myelin that's created, and new pathways are made. And when you do things correctly, you're creating basically a super highway, right? But then when there's lack of usage, like you were saying, those highways break down, right? Or like you think about ancient trails that are used, when people use them, you know, they're great. But then when people no longer use those trails, the trails start disappearing, right? Similar analogy to the neurons, right? So you're trying to create new pathways and train these neurons to do different things, right?
Yes.
So, what other insights around the neurons? What are you seeing at the basic level of neuron? What are you seeing? Are you seeing any unique behavior things that are like, wow, and because there's also things that maybe some of the insights you're getting from this that can be applied to help people out with brain injuries or learning disabilities or other things. There are probably a lot of insights that you can gain from this that can be applied to other spaces too, right?
Yes, absolutely. Our research could contribute to also biomedical, although it's not our objective.
Yeah, of course.
What we learned about neurons is that they're not stable system, in contrary to computers. So it makes more difficult to work with them because neurons are changing over time, and the input you give today can give one effect, and tomorrow it can give different effect. So this actually makes the work with neurons even more difficult.
How long do let's talk about stability, right? And how long
Mhm.
can these neurons last in a sense, right? Before they kind of break down or become inefficient or unresponsive, and is there a certain threshold? Is it 60% degraded, and how long? I guess when you think about maybe it's not the correct term, but what is the half life of a neuron in a sense, right?
No, actually, half life is when things are half dead
Yeah, I know.
in the middle. So in the neurons, it's not. It's a bit different because either they're alive or they are dead.
Yeah,
So there is no half life in the between. So they currently can live around 3 months in our lab, which is actually great success for the industry standards because it's very difficult to keep neurons alive in the dish. And we are of course planning to extend this time because in nature we can see that neurons can live even 100 years. So we think that in our lab they can also live longer, and we are constantly working on this.
right. And that's what I was thinking. Is like that was my guess, just from little I know, that it'd probably be around 3 months. So if you're going to use this for processing in the long term, right? You know, some of these like NVIDIA chips or whatever can last a while or whatever, right? So what do you think is that duration it needs to be able to live or be useful, right? Is it 6 months? Is it a year? What's the goal to?
No, actually our goal is even maybe 100 years or many years. So we would like to push this to the maximum or whatever is possible technically.
Well, that'd be interesting too. We go back on the medical side too. If you get these neurons to living 100 years, people are going to try to leverage those concepts to live much longer too, right?
Mhm.
Okay. So let's talk about democratization, right? So what do you see as the key challenges and opportunities in making AI accessible to founders, regular people, businesses, people from a variety of industries and experiences and backgrounds? How can we bridge this gap?
I think that currently there is not a big problem because AI is not expensive yet. So if you want to improve your work, I think you can use it quite well. I think for the startups, I personally think if someone has a startup idea which requires, millions of dollars to build, that's not an idea really, because that's not the point. The point is to have something idea how to do things cheaply and efficiently. So I've heard a lot of ideas, that people say that if they would have $10 million, they would build something, but that's not really startup idea. That's more for a corporate project, I would say. So I think that currently it's not a problem. I don't see a problem of adoption. You just have to learn how to use it. So it's or the willingness to learn new stuff. But I see this on the future because I think that AI becomes more and more potent. That means it will cost more energy, and also if we use it for more and more processes, then it will cost more. And also I think now also the pricing of AI is a little bit lowered because companies which are producing LLMs are still they want to have more adoption, so they want that people get used to use LLMs. But once this happen, I think it will also be just more expensive. So for example, the subscription today you can have ChatGPT already for $20 per month. I believe this subscription will be much more in the future. So I think that's more the future. At least as I see this today.
I think you brought up a good point too. Is like if you're doing a startup and you understand a pain point that your target segment, you're solving a pain point that your target segment really needs to address, right? They're going to be willing to pay for it, right? Like in a sense, I would never want someone to put a hot blade on my arm, but if I was bleeding, and I would pay somebody $100 to put a hot blade on my arm at that point, right? So if you're actually doing something that's valuable, that's going to solve a pain point that you have a potential client base, you don't necessarily have to go raise millions of dollars in a sense, right? And because the clients will come to you, you're kind of more of a market magnet in a sense of versus having to do a lot of outreach. And so I think that's an important insight I've gained in the last couple of months as I've been doing stuff on my own, then also working with different clients, et cetera, too, is like really identifying that pain point. Do you have a solution, an approach to actually address that pain point with quality, with cost, right? And to get that client to the next level, right?
Yes, absolutely.
Okay. So let's get into ethical AI. And I think we're also going to talk about the future of AI. So how can we balance AI innovation with responsible development?
I think this is a question maybe for philosophers. What we shouldn't do with AI? We are engineers, so we try to make the best what we can, and I think maybe philosophers should give us some guidance on that.
Well, because the reason I asked this too, even some of the biggest scientific minds, Jeffrey Hinton and other folks, they recently signed a statement of AI risk, right? In terms of, there are a lot of people believe that AI could be an existential threat to humanity in terms of if it's not put on the certain guardrails. And I think those are things we have to think about now before we unleash Pandora's box and and get to a point where there is no turning back, right?
Yes, that's true, and we have to make sure that AI is aligned with our objective, our interest.
Yeah, so let's to be, because on the show we want to discuss what's real and practical and always bring up points and not just I'm never going to be a shill or a hype person, right? So let's discuss some of the dystopian and utopian scenarios, right? So let's go to the dystopian, which is like, because even on the butterfly thing or other thing, even when I post something on AI, people are like, why are you posting about AI? It's going to end humanity. Or someone will comment,
Mhm.
oh man, humanity's cooked, especially when they hear about this type of thing. So there's, how do we address the concerns that are we creating like a matrix scenario or, like an Atlas cloud that, that humans will be harvested as biomatter and fuel, how do we address those? We're going to get people that, whether it's investors or, anybody that have these kind of concerns. How do you address those concerns,
So I think that's philosophical questions, not for engineers and scientists. So I don't know. I don't know. I think they should help us to answer.
Yeah, no, well, that's why I have this show is like, because I think
Mhm,
we all have, because the engineers and scientists have to think about these consequences, right?
mhm.
And the people that are building these companies, the leaders of the companies need to follow the frameworks, need to develop the frameworks and think this through, right? Because, or you get, people that are looking at, even some of these vaccines that are coming out there, right? There's people that are testing vaccines that would have good intent, but if it's not done in a controlled way and it gets unleashed onto society and and people get ill and other things, I think those are things we have to make sure that, or even a nuclear reactor, right? We're building nuclear technology, right? Engineers are building those things, but governments and people and the leaders have to make sure that the security and safety measures are there so that the radiation doesn't leak or whatever. And those are things that I think everyone needs to think about in what they're doing, right? Are we doing this in a healthy and responsible way? So what do you see as, we've talked about some of the dystopian, but what do you see as some of the utopian or good things of the future coming out of this technology, right?
I don't think I have a utopian vision. I I think we are just trying to make a world a better place. We try to make better technologies. I don't think it's utopian.
And I
So
agree
I
with
think
you.
we are,
There's no utopian. There's
I think we are just we have quite pragmatic approach. We want to make technology which is working, and I don't have any idealistic vision about about everything being perfect, but we just would like to do AI, which will be more energy efficient, cheaper, and more accessible, so that we can do more efficient automation with less cost. So that's our objective.
Right. And I think some of the things that we can do is if we can do things in an efficient way, cost effective way, and an innovative way, can we
Mhm.
find using this technology new solutions to solve you using AI to solve some of the things that humanity has been struggling with, right? In terms of finding new solutions, new ideas,
Mhm.
use especially on the generative AI side, can we use this technology to maybe find new cures for diseases, by faster processing times to analyze, say cancer cells or what have you. So there may be other
Mhm.
applications. Maybe those are things you guys are not focused on, but coming out of what you're doing, maybe other companies can start looking at some of these scenarios, right?
Yes, absolutely.
Okay, very good. So in terms of, we always like to give some encouragement to those that are kind of getting into the space.
Mhm.
Maybe there's a young scientist out there or a young entrepreneur out there right now that's listening to this, right? Or someone that's struggling in their business, trying to get
Mhm.
things going. Do you have any concluding thoughts, insights, or encouragement to those seeking to get into the AI space or struggling to build their business?
Well, I think these are two different things. I think if you want to get to AI, I think it's quite easy because there are so many resources on the internet on every level you want. You can become engineer or just a user. So I think it's quite easy today. There are a lot of courses, a lot of discussions online. So I think it's not so difficult. And if someone is particularly interested in biocomputing, I encourage to check our website, finalspark.com. We have a lot of resources on this website. You can also send us a message. We have contact form on the website. We answer every message. So if anyone is interested or has any comments or suggestions or ideas, then it's very welcome. So we encourage everyone to get in touch.
Yeah, I think in the past, if you're a business person in like a startup environment, AI. But I think with AI now, if you're a technology oriented person, a scientist, there's
Mhm.
so many opportunities out there. People are looking for the scientists and the sharp minds that can help shape the future, right?
Yes, absolutely.
So
That's
this
true.
definitely an exciting time to be someone with a scientific mind in terms of going forward. So, Ewelina, I think we're coming up on time. I can talk to you actually probably quite a bit more and getting into the technology and the future of this stuff.
Mhm.
But for our listeners, where's the best place where they can learn more about Final Spark or connect with you?
So as mentioned, our website, finalspark.com.
And
That's
what about,
the best way to get in touch and check about the project.
all right, and can they connect with you on LinkedIn or how does that work?
Absolutely.
Okay.
On LinkedIn, we are also there.
Okay, very good. Well, fantastic. Everyone, make sure to check out and connect with Final Spark and Ewelina Kurtys. Don't forget to follow us on LinkedIn, subscribe to our YouTube channel, and find us on your favorite platforms like Spotify and Apple. Ewelina, I've learned quite a bit from this episode. I can't thank you enough for your sharing your insights today. I'm your host, Sanjay Kalluvilayil, founder and CEO of Stonehaas Advisors. I hope you gain a wealth of game-changing real-world insights to grow, transform, and scale to new levels and dimensions leveraging AI. I hope to see you all next time. Thanks so much.
Thank you.